So usually like motors and generators are on question 10. So this is the 2018 November question paper. We're gonna do like this question 10 real fast. But first, like, is there anything you wanna ask me about like motors and generators?
To be honest, I really don't have a question at the moment. Actually, I don't have any question right now. Actually.
Okay, so like, what do you know like about motors and generators? Like, just some general information.
I know the components that go into AC as well as DC, and then I know about how to determine the direction and also to determine the maximum and minimum magnetic flux and those type of things. So essentially we did the entire topic almost. So we almost done. We just need to do some more questions regarding the calculations, and then we're done with the whole topic.
Oh, so to you, is it like hard? Because for me back in high school, it was very complicated, but now I had time to go through it and I understand it.
The kind of difficult part for me is at first was to understand the how do I say how to determine the direction and stuff. I didn't really understand not the direction as such, but the coil, those things where they talk about the coil and then they say once it moves into the how do I say into the magnetic field and then it's at a maximum, and it was a bit confusing at first.
Oh. So like just like let's just get into it. So I'm just gonna have the chat on the side because if I remember, someone else said they're in a loud area. So let's have this. Let's have this here. So they say in a simplified AC generator below, the coil rotates clockwise. The coil is rotated clockwise, and they show you like with the arrow of where the rotation is. Then the first question is which direction does the current flow in the coil?
Oh yeah, this is actually something I need a recap on. I need to know which hand do you use when
The
you're
right
speaking
hand.
about, so right hand for generators, right?
Yeah.
Okay. So let me just try and determine this.
That's why like I have this other video on standby just so like if you guys don't understand the right hand rule, it explains it nicely there.
I think it would be beneficial if you actually send it on the group. But my answer is it's moving from Y to X. So it's moving towards you as a, I don't know, moving towards us looking at it.
The thumb is for like the direction of the magnetic field.
Yes, that's true. All right.
Then what's this finger next to the thumb again? What do
Which
you
one? The pointing one.
Yeah, the pointing.
Yeah.
So we know that in the magnetic field, it's gonna go from north to south, right?
Yes, that's true.
Okay, so oh yeah. You're right. It goes from Y to X.
Oh, okay. Thank you, sir.
So we can go on to like the second one where we say which principle are generators based on? Like it's not that hard. Like the thing is, if you remember the scientist name, then you know the principle. You don't have to write it out. You just have to state the scientist's name.
Um. Oh, is it Fleming?
Sorry?
Is it Fleming? Because I know there's something as Fleming's right-hand rule or left-hand rule. I'm forgetting now which one.
No. That's just the rule for that's just a rule used in a generator. But a generator is based on another rule, another law.
I'm not sure. Again, the other people in the call, please help out you. I don't know.
Because I think like there's 3 of you guys. Like, if you can't talk, you can just like type it out in the chat. So let's say I'm gonna wait like 2 minutes, and if there's nothing in the chat, then I'll give you the answer. Is that fine?
Water.
Okay. So it's been like a minute now.
Oh, so is it Faraday's law?
Yeah, exactly. It's Faraday's law. So the generators are based on Faraday's law. Then we're gonna get to like 10.3. They say state the energy conversion that takes place when a generator is in operation. Like, you guys understand how a generator works, right?
To an extent.
Well, to an extent. So
yes.
let me just show this to you real quick. But I'm gonna mute it, because like it's gonna give you guys the answer. So I'm just gonna mute this video. Can you guys see it?
Yeah, can see.
So like this is how a generator works. An alternating current generator works. You can see like with the coil moving and everything. Right? Did you guys get that?
Yeah.
So the coil is gonna move inside the magnetic field, So the coil is gonna move inside the magnetic field. Then let me just draw this real quick. The magnetic field is going in this direction. So as the coil moves, that's kinetic energy, And that's kinetic energy, or it's called mechanical energy. And that mechanical energy is the one that's converted to electrical energy, because generators are used to generate electricity through the motion of the coil. Do you understand that part?
Yes, makes sense.
Yeah, then like the energy conversion that takes place is mechanical energy to electrical energy, or kinetic energy to electrical energy. Does that sound good? So can we move on?
Yes.
Sorry?
Yes, I believe so.
I thought like someone was talking, so I wanted to give them like an opportunity. So we're now gonna get into this, the AC generator graph. Like those of you guys who were there with me on Thursday at Noble Park, like I showed you guys this graph, right? Then they say the voltage output of an AC generator is shown in the graph below. So this is the voltage versus time graph. Sorry about that. Then they say write down the maximum output voltage of the generator. Like I think it's a simple enough question that you guys can be able to answer it. Or if you want, you can just write it down in chat. Okay, that's good because like it's gonna be 340 volts. So that's the peak output of the generator. And now we're given a stove. A stove is connected to the generator above. Whether, let's just say the generator that is represented by this graph. Then and it delivers an average power of 160 watts. Then now they say calculate for the RMS voltage delivered to the stove. Do you guys know do you guys know the equation for that? So when you have the voltage and you have to get the RMS voltage, I'm just gonna call it that because I forgot what this RMS means. So I'm just gonna like the equation given to us to calculate the RMS voltage is that V R as the RMS voltage is going to be equal to the maximum voltage divided by the square root of 2. Oh, yeah. So I just remember RMS root mean square. So this is the root mean square voltage. So do you guys understand the equation? Or are you guys familiar with this equation? Okay, so like you can just use this equation now and you get the RMS voltage delivered to the stove. Can just like get that real quick and write it out in the chat. You know, so at least like I know you guys are actually doing it. $340 divided by the root of 2. Yeah, that's correct. So so the RMS voltage is gonna be 340 volts divided by the square root of 2, which is gonna give us 240.42 volts. So after this is our answer. Let me just rub everything out. Then the next question says calculate the resistance of the stove. Do you guys know, like, since you haven't reached this point of like the root mean squared volume, at least, like, have you guys reached the resistance part of a generator? I mean, how to calculate resistance when given power and voltage. Okay, so that's a yes. So with that being said, can you guys like give me the formula? If any of you is like able to speak, can you give me the formula real quick? Or can you just type it down in chat? Just use this to show that you're dividing. So I'm just gonna wait like for 2 more minutes. Then if you guys don't know the equation, I'm gonna give it to you. Yes, that's correct, but like P is equal to V RMS divided by R. V RMS squared, yeah. So that's nice. So from that, we know that our power is 1,600 watts. Then if you want, you can just make the resistance the subject to the formula. Therefore, you'll have R 1 over R. It's gonna be equal to, when this goes to this side, all to P over V squared. Therefore, you get the reciprocal. Then it's gonna be R is equal to V squared over P. Let me just write RM. Do you guys agree with that? Okay, so I'm just for me, I'm just gonna use this equation. So where's that eraser? So we have 1,600 watts. Where can I write these things down? So R is gonna be 240 0.42. The whole thing squared divided by 1000. So like, have you guys gotten the answer already? Can you just type it? Can you just type it down while I calculate? Okay, nice. So that's 36 point. Oh yeah, it's actually 36.13, because when you convert the 6 is gonna round off the 2 to a 3. So 36.13 ohms. So guys, that's the question from 2018. I wish most of you guys could speak, because like it would be better if we have a chat about this. But from you guys, is there anything you have to ask me, or is there anything in physics that you find hard that you need that I should help you with? Because like we can't just focus on this only while you're struggling with other topics. So is there anything that you guys need help with? Where's that chat? Okay, acids and bases. So guys, like I don't know whether we're supposed to be doing like the whole of physical science or only the physics part. But since you guys already know like electric circuits and all that stuff, we can do like whichever topic that you guys want, as long as it's within physical sciences. So can I just go on and do like acids and bases? You guys can just vote in the chat with like a yes or a no. Yeah, then I guess like because like it's only you and like no one else is saying anything, we can just do like acids and bases. Can you just tell me what you find difficult about acids and bases? So I can just get a feel of like the knowledge that you have and the knowledge you need in order to like get better at acids and bases. Acids and bases, acids and bases. Broma. Oh yeah, this is organic chemistry. Uh, so is this like is question 5 good? Can we do question 5? Because I think question 5 is the one based on acids and bases. Oh, this is chemical equilibrium. That's chemical reaction rate. So guys, this is question 7. I'm sure that this is like the acids and bases part. So I mostly like skip the definitions because I know like it's just 2 marks. So the definitions are for you guys to like memorize and stuff. So they say name of write down the name of formula of the substance that acts as an ampholyte in the above equation. So do you guys know what an ampholyte is? Yo. Like you can just type it down in the chat if you know what an ampholyte is. I'm just gonna like give it 2 minutes. I'm pretty sure that's enough time to type it down. Then I'll give you the answer if after those 2 minutes that nothing appears. Okay. So it can act both as an acid and a base. So from the equation, from let me just highlight these equations. From these 2 equations, which substance can you identify as an ampholyte? Like I know it's really hard to write numbers down here. You don't have to do that. If maybe let's say you think sulfuric acid is the ampholyte, you just write H2SO4, you know, then send it over. it doesn't matter whether like it looks like a chemical equation or not. So guys, which substance do you think is an ampholyte? I'm just gonna give it like now. I'm gonna give it a minute on this one. Can you guess again? Sorry, can you try again? Like, look at these two equations and think which substance actually acts as an ampholyte. Acid. Exactly. Yeah, it's water, H2O. Because with water, I think like also you guys you were right with like H2SO4 because that there's two hydrogens and water can either can donate one of those hydrogens, but it can also take one of those hydrogens. As you can see here, like water can donate one of these hydrogens and this changes to OH minus. Or it can take one of an acid's hydrogen and it becomes H3O plus. So water is the ampholyte of the equation. Then they say give a reason. I think I just gave a good reason. But anyway, they say the conductivity of the solution of HSO4 minus and H2SO4 are compared. Which solution has a lower conductivity? I'm just gonna give you guys like two minutes because we're on like 5 minutes now. When like there's 3 minutes left, I'll give you guys the answer. Can you just like find it out and type it down on the chat? So guys, since like it's like 3 minutes left, I'm gonna tell you. Oh, okay. regarding conductivity, but I said issues also as in oh, that's the thing. Like I think the thing is it actually conducts more when it's an ion, and it doesn't conduct more when when all the shells are full. So actually the one of higher conductivity is this one. Yeah, it's just a guess, but I like it. That's a nice guess. But it's just that ions increase the concentration, and as the concentration increase, the conductivity also increases, you know. So let's just say it like this. Since we have 2 minutes, I'll just make this analogy real quick, then I'll start another class with you guys after the meeting ends. So let's say you put water, you put salt inside water. You won't taste the salt until you dissolve it, you see. So once you dissolve the salt, the concentration of the salt starts spreading out throughout the water. So like once like you drink, let's say you have 1 cup with salt and water inside it, but the salt is not dissolved, and the other cup is salt water inside it, and the salt is dissolved, you know. So where there's higher concentration, there's going to be higher conductivity. So since you're going to dissolve the water, it breaks down and forms ions within the water. Thus, the ions have more conductivity than the actual compound when it has a full shell. So let me just like get back to this real quick and restart the meeting.